a container with a square base is to have a volume of 300 inches cubed. The material for the top and the bottom of the container will cost $2 per square inch, and the material for the sides will cost $6 per square inch. Find the dimensions of the container of least cost. First, we start out drawing the container. X's, and we know that volume equals 300 inches cubed, and we are looking to minimize surface area, and the equation for that would be (2x squared plus 4xh). And we'll take these and we'll multiply the x by 2 because it costs $2 per square inch for the top and the bottom, plus 6 for the sides, it costs $6 for the sides, times 4xh. And then we'll do our volume equation, which is V equals x squared h. You know 300 is the volume, x squared h, and we don't want two variables. So we're going to divide the x squared out, solving for h. So we have our h, and we'll plug it back into this equation. For me? I don't call my after school. And this is our equation, and we're going to begin to simplify. And we'll cancel out one of the x's. We'll be left with 2 times 2x squared plus 6 times 4 over 300x. And this is our simplified equation. And we're just going to go ahead and distribute and begin to derive. 4x squared plus 7,200 x to the x to the negative 1. Alright, and taking our derivative with respect to x, will be 8x minus 7,200 x to the negative 2. Go ahead and move this x to the negative 2 so we won't have a negative exponent down to the bottom. Go ahead and get a common denominator, which will leave us with 8x cubed minus 7,200 all over x squared. Set this up equal to 0, solve for bottom and the top. X equals 0 is not really relevant, so we won't use that one. And then we'll have 0 equals 8x cubed minus 7,200. We'll go ahead and divide the 8 out. Take the cube root. Left with 9.65 for our x. We'll plug it into a sign line. Say a number smaller than 9.65, we'll go ahead and use 9. Plug it into this equation and we'll get a negative number. We'll use 10, plug it in, and we'll get a positive number. So we are minimizing, going from decreasing to increasing. So that checks out. We'll go ahead and plug our 9.65 into this equation. Remember, x is squared. And this equals h, so h equals 3.22. So basically what we have here is we have 9.65 for our x's, and we have 2 of those, so 9.65 times 9.65 times 3.22 will be the minimum amounts that we need for our surface area.